So next we're going to take a look at question 8.3.26. It says, use the magnitudes of the earthquakes listed in dataset 21 earthquakes and test the claim that the sample is from a population with a mean greater than 2.50. Use a 0.01 significance level. So one of the things that we're going to need is the claim. And our claim here is that the mean is greater than 2.50. And just so we have the opposite or negation of that, that is the mean is less than or equal to 2.50. So now we've got everything that we need to write the hypothesis statement. So we've got the null up top, alternate on the bottom. It's mu, it's 2.50. So whatever parameter we see, whatever number we see, come right over to the hypothesis statement. And in between them in the null is equal because it's always, always, always equal in the null hypothesis. The alternate gets the strict inequality. We'll do our little bit extra here with the R and the S. And now we're wondering which one looks most like the claim. And that is, I'm just having too much fun drawing here, the alternate hypothesis. So when we get down to writing the conclusion in part F, we're going to talk about whether or not it's S. S is for support. We're going to talk about whether or not we can support the claim that the sample is from a population with a mean greater than 2.5. Or 2.50 since we're going out 2 decimal places. The only thing that we're missing is whether or not we have the evidence to do this. So we're one word away from having our entire conclusion, and that word comes from here. If we do, we do. If we don't, we don't. If we do reject the null hypothesis, then we have sufficient evidence. If we fail to reject the null hypothesis, then we don't have the evidence. We have insufficient evidence. So moving back to part B, this is going to be a right tail test because our inequality in the alternate is pointing to the right. Our significance level is alpha. Again, that's at 0.01. And this time around, we're given data in a data set, so we really don't have to do this right now. We kind of don't have to worry about this right now. Now, in the real world, we would still get that information that would still get listed in the write-up of it. And I can walk back to that at the end. But for now, let's just continue carrying out the hypothesis test. And before we go and get the test statistic and p-value, let's write our rule of rejection. And that's reject the null hypothesis if p-value less than or equal to 0.01. So since we're going to use the sample standard deviation, our test statistic is going to be t. If you didn't know that, don't worry about it. StatDisk is going to tell you that. And then we also need our p-value. And again, I'm lining up the p-value right underneath where I have it there to make sure I'm making a better comparison here. So let's head on over to StatDisk. Let's get rid of our previous one. And they said data set 21. So there's our earthquake datas. and then we're testing the magnitude, which is in column 1 here. So analysis, hypothesis testing, mean 1 sample, and this time they were wondering if it was greater than. So I'm used to asking that as a question. Yes, it's greater than.
A little different in this format, isn't it?
Yes, it is. Significance is 0.01. Our claim mean is the 2.50. And this time around, we have data to use. So we click on use data, and then we just pick the column that we want to use. And we're testing magnitude, so we want column 1. We can hit evaluate. We can also go ahead and hit plot. And what we see here is we do see that our blue of the test statistic is falling beyond the red of the critical value. We landed off in the tail this time. And our p-value, 0.0033, that is less than our significance level. So let's take this back on over to here. So our T was 2.721. Our p-value was 0.0033. And again, I line them up because I've seen too many people try to compare the 3 against the 1. They're not in the same place value. We don't compare them. So our p-value was less than alpha. So we do go ahead and reject the null hypothesis. And when we reject the null hypothesis, we have the evidence. So we'll put the sufficient there. So we have sufficient evidence to support the claim that the sample is from a population with a mean greater than 2.50. So where did the 2.50 come from? Typically that's been from past data that they've had, past samples. Somebody was probably wondering, hey, we think that we're dealing with mean magnitudes that are greater than what we've had in the past. That's what we went ahead and tested, and that's what we have evidence to support the idea that the mean is now greater than 2.5. What is the mean actually? We don't know. If I go back to our other screen though, we do get a confidence interval there, and that confidence interval is telling us that the mean would appear to be between 2.51 and 2.63. So we can use the confidence interval in this case to get an idea of where the population mean now lives. And we do see that is that entire confidence interval is above the 2.50. And going back and taking a look at the picture there, we do see that our p-value is the size of the tail that the test statistic cut off, and our significance level is the size of the tail that the critical value